Well, good morning. Here we are again. I just want to hit you guys with another test or two. I may try to do a series of these if I can find the time to scrape them together. But this is a little 10-question test, and I got the answers to each slide right behind the first slide, so maybe we'll be able to go through this one pretty quick and I won't use up a lot of your time. Question 1: which component is not used in a brushed permanent magnet motor? The armature, the field coils, the brushes, or the commutator? Now, these are the field coils. The commutator is back here. The armature is this part right here. And so, you got brushes right here. There's a brush right there. All right, the answer to that would be the field coils. They've been replaced by permanent magnets. And typically you're going to find out that permanent magnet starters not only are a little smaller than a starter with field coils, they will also typically have a planetary gear set in here that will increase the, those permanent magnet motors spin really fast, but they got planetary gear set to increase the power going to the ring gear. Now, the old Chrysler starters that sounded so odd back in the 60s and 70s that would go, you could hear a Chrysler starter all the way across the parking lot. No, that's what you were hearing. But they had planetary gear sets way back then, even though they had field coils. I don't know if you knew that or not, but anyway, on a brushless permanent magnet motor, the permanent magnet is located A, around the outside, B, on the rotor, C, on the commutator, or D, in the controller. Alright, this right here gives you a little bit of a rundown on this. Wait till that starts animating and you'll see them spinning. See, you've got your brushes right here that are delivering power, and every time this thing goes around, the polarity is reversed and it forces it to turn, and it's a repeating cycle. Well, on this one here, you have to have some electronics to make this one work. Even if you take a computer fan, one of those 12-volt computer fans, like what goes in your PC, and you tear that thing apart, you'll see a little electronic circuit board in the middle of it under the hub of that fan. That's just the way it is. So basically the magnets are on the center part instead of the outside if you've got a brushless motor. That's also the way that the motors in these hybrid vehicles work. And so, they basically have the magnet on the inside, but now they run on alternating current. And the fuel pumps on some of your GM cars and some of your others now are basically brushless motors like that. They've got a little controller that walks the current around. Question 3, a cranking current draw test on a cold 4-liter V6 gas engine shows a 375 amp starter draw. The ambient is 60 degrees. The engine starts and runs normally. What is the most likely cause? A, B minus voltage side drop. B, wrong crankcase oil. C, loose alternator belt. Or D, a defective starter. And the answer would be a defective starter. You got high current there, you're typically going to wind up finding a starter that's pulling too much current. Now, that's the most likely cause, because if there's some other reason that the engine is hard to turn, like if you've got something locked up, like one of your accessories is harder to turn than it should be, like the AC compressor bearing is locked up or whatever on that idler hub. Anyway, but you'll have squealing belts typically then too when it starts. Question 4, what type of alternator stator has each phase winding connected to a common point? Now, these 3 little lugs here, they connect to the rectifier bridge. When that rotor spins inside here, it's only got about, notice it's got this metal laminated core that greatly increases the force of that magnetism. And the magnetism is actually in the rotor as it's spinning, sweeping that magnetic field across these, and that's what creates that alternating current that's rectified by the rectifier bridge. However, there's a couple of different ways these stators are wound. In other words, if you unwound this thing, it would have one of two configurations. It would be either a Y-type stator or a delta wound stator. Now, each phase winding is connected to a common point in a Y-wound stator, but you see on a delta wound stator, it's still got three connections, but it doesn't have a common point for each one like this one does. I used to, on some of the Ford alternators long years ago, I would find an alternator that wasn't putting out, and you could see the place where this connection was made. It was all put to, twisted together, and how they sort of weld that copper. And what I would do when I would see that it had scorched and burned and it had come apart right here, and it was laying in here somewhere usually, I would clean that stuff off and do a really good job soldering it back together and fix the alternator. I enjoyed fixing stuff more than I enjoyed changing parts, so sometimes I would fix things instead of changing the parts, Back in the day, back in the 70s when I started, we would routinely rebuild starters. We would rebuild alternators. Back then there were not as much as starters. Starters were the most common thing we rebuilt. Whenever we did a brake job on drum brakes, we would rebuild the wheel cylinders. The boss man in there, the shop where I worked, he kept various different size wheel cylinder cups in there, and we would basically rebuild the wheel cylinders. We'd hone them out and all that. It was standard procedure during a brake job. Question 5. Measuring available voltage to a component requires the multimeter to be connected A, in series with the load, B, parallel with the load, each parallel with each load, or just ahead or before the load, or just behind or after the load. This is the way that I would do this, and you can come up with a zillion different ways, but typically if you're going to see how much voltage is available to a component, you notice I got this set on the 20 volt scale, and we're reading what's available to a component. This would be with the switch closed, right? Okay, but here's the thing. If you take your meter and you put it on amps, of course I didn't fix the leads, because if you're going to put it on amps, you're going to have to put the red one here. Yes, that's a mistake that I made when I was creating the illustration. Duh. I'll fix that so that the next time I use this anywhere, I won't look like an idiot, because you're going to have to move this one up here. The problem is, if you move this lead up here and leave it up here, and then if you don't move that lead up here, you'll pop the fuse in the meter, basically is what it amounts to. In other words, if you hook it up, if you hook it up like this, and then you connect it this way, with this one in that hole, that's when you'll blow the fuse in the meter, and that happens all the time. Some of the meters will have a fuse that costs $12, $15. This whole meter right here costs about $10. I bought a bunch of these when I was teaching over there, because if they stole it or ran over it or whatever, you hadn't lost anything much. Question 6. When testing the integrity of a load ground connection, the best tool is a quality DVOM, an LED test light, a headlight bulb, or inductive probe. All right, now pay attention to this. When you use a load that's going to be, as nearly as possible, mirror the load that you're testing that doesn't work. If you got a bad ground that you suspect because the fuel pump's not running, a low impedance test light only pulls 1/4 of an amp. And low impedance meaning it's got a regular little bulb in it, like a little, marker light bulb type size thing. And I think they call that GM191 or something like that. But anyway, this headlight bulb is going to pull about 5 amps. All right, now what I'm going to do now is I'm going to close this relay, because you're going to have to close the relay before you can check the ground the way I'm showing you. All right, close the relay, the light comes on. If this lamp is pulling 5 amps and that pump pulls 5 amps, you know that the ground is a good ground. Now I've got a video on my YouTube channel that says why a meter and a test line aren't enough, and we had a trainer truck that suddenly just lost fuel pressure. And so said, well, we need to look and see what's going on here. So pulled the bed off and slid it back out of the way so we could see the pump real good. And so I could connect a test light. I could disconnect the pump, and I could connect a test light between the 2 wires of power of the ground going to the pump. And whenever you would energize that fuel pump relay, that light would come on. But the pump still wouldn't run. you know, when initially we thought, well, there's power getting here, so the pump's good. So, but when we put power and ground independently to the pump, it would run. So I took a headlight bulb that I had in a container, kind of like this one here. You put that in there so you're not touching the bulb and it's not too hot, it's not going to burn you and all that kind of stuff. Put it in a baby food jar or something like that. You know, you're going to have to engineer that. But it would not burn that headlight bulb, but it would burn the test light. And it actually had a bad ground. And so that was something. You can look that up on my channel. I should have put a link to it. While a meter and a test light aren't enough, you can see that little job we did in the shop. Question 7, a digital voltmeter is used for cold cranking amps tests, specific gravity testing, open circuit voltage tests, or reserve capacity testing. This is actually my meter. I bought it on the Mac tool truck back in probably 1995, and it was like $400. But you notice this meter right here will measure pulse width milliseconds. Isn't that something? It's got it's specifically automotive, and it's got a lot of cool stuff. It's also got temperature measurements. You can hook your your temperature thermocouple up to it and all that. And I've still got this meter. It's really a good one, and you can tell ET332 Mac. You can't get them anymore. They don't make them. But that was a good meter, you know. Open circuit voltage test. Now you notice I didn't say digital volt ohm meter. I said digital voltmeter. I left the ohm part of it out. Question 8. The circuit shown is A, a series circuit, B, a parallel circuit, C, a rectifier circuit, or D, a stepped circuit. Okay, this is a parallel circuit. That's what it amounts to. The stepped circuit would be like your blower resistor, is what that is. A rectifier circuit's going to have diodes in it. A series would have these all in a line with everything flowing through every one of them on the way. Here's a question though. The resistance reading between point A and point B will be approximately what? Well, let's see. If I did the math here, I got 5 and 3 and 1. That would be 9. No. What you're going to do when you see a parallel circuit and you want to know what the resistance is, it's always going to be less than the least of these. So if 1 ohm is the littlest one, and if you see this on a written test somewhere, and this happened to me at Ford School, it's going to be less than the least in these parallel resistors, because every one of these, I always tell my students, resistance is like the size of a hole in a bucket. You know, the water in the bucket would be, what's flowing. Okay, so if you make a big hole, you're going to have a lot of water flowing, right? Because you don't have much resistance. Well, the higher your resistance goes, the smaller the hole is. So let's say you've got a 1 ohm hole, and you add a 3 ohm hole and a 5 ohm hole. That's going to be equal to a larger hole than a 1 ohm hole. That's the best way I can describe that. I always try to come up with ways to describe it so my students would understand it. 0.6 ohms. That's the deal there. Question 10. When a component on a schematic is drawn with a dashed or dotted lines like the one shown, what does it mean? Is it a transmission input? That it's present on all vehicles? That some of it isn't shown here? Or that all connections are negative? It basically means you're not seeing the whole component. If you ever see that dotted box, there's more to the component than you're being shown on there. Well, this has been a really short test. We've been here 13 minutes and 26 seconds so far. I think I can bail out of here by the 14-minute thing. I hope you guys got something out of this. There will be another test with different questions for A6 coming next week. So tune in for that one too, and let me know what you think about this one, or if I got anything wrong other than that stupid meter thing where I put the port wrong. Anyway, we'll see you guys next week.